Thank you all for coming to this session. My name is Suresh Sriramlu. I work at a company called Orbia Fluor Energy Materials, where I've been involved in developing battery materials for many years now. And I'm really happy to be here today with discussion on energy storage. We already heard earlier today of how important energy storage is, but I will ask our panelists to describe in their view how energy storage is important for this energy transition. But very briefly, as Mr. Sujoy articulated so well at the beginning, the energy storage is, we are seeing an energy transition today with increasing use of renewable energy to support our grid and make us energy secure and also improve our quality of life for our citizens. But a key component of renewable energy is that it's intermittent, it's not continuous, and we need energy storage to be able to absorb that energy and be able to equalize the power produced in the grid. So energy storage is very important, and by and large, batteries are the primary form of energy storage that has the flexibility and the cost performance structure to be able to be widely adopted in the industry. So with that, I will ask our very exciting panelists to tell a little bit about themselves and how their organization and the work that they are doing is going to help us with this energy transition. So we'll start with you, Devi Prasad, and then we'll go around.
Thank you. Energy storage is not limited only to the renewables, like it is a Swiss knife for power electronics to mobility to renewable integration. We work with multiple industry stakeholders and work in the manufacturing, raw R&D, and also on the raw material and processing side. And good to know, like yesterday we got a announcement of 34,600 crore for the critical minerals. Out of that, 7 critical minerals are related to batteries. So under critical mineral missions, like which includes cobalt, lithium, nickel, also on the vanadium and copper and other materials. So hopefully that will boost the manufacturing. Similarly, we also work on the grid side. Last year was an interesting year. India saw around 16 gigawatt of energy storage. Yes, the price point is a discussion point. What price point these projects has been awarded to the companies, but it's a very humongous number. 16 gigawatt number of energy storage projects is coming in India, and India has already experienced multiple projects. And the other part is on the manufacturing side. Still we are importing cells, and we work with government on creating SEC PLI, where 3 companies are setting up the gigafactories. And beyond SEC PLI, there are more than 10 companies are setting up the gigafactories of advanced lithium chemistries. But there are other companies who are also working on the small scale manufacturing of non-lithium chemistries like aluminum-based metal air batteries, vanadium, zinc-based batteries, sodium-based batteries. So beyond that, to make it circularity, we also work with 20 plus companies who are working on the recycling of batteries, because now most of the batteries which are started using in the power electronics and telecom infrastructure, not in mobility yet to come for the second life, but telecom and power electronics that started coming for the recycling. So many companies have already started doing the recycling activities on the same. So considering this ecosystem, it's a very well-developed system now. Many companies have, it may be large conglomerates like Tata or maybe Reliance, they have already diversified. Multiple startups, including Ola and others, are entering this space. And it's an exciting segment. So we need to see how this segment is not only limiting to India, how we can create an ecosystem which can export to the other countries and can be a R&D or manufacturing hub for many countries, because with a China plus one strategy, how we can work with Europe, Middle East, African countries and US and other markets, so that we can create a ecosystem on the energy storage space. Yes, thank you.
Thank you, Devi Prasad. Maybe Satya, to you.
Good morning, everyone. It's again a pleasure to be back here in the campus, being an alumni. And today, definitely, we don't need to emphasize the need of energy storage. You know, with so much of grid disturbances, and we have seen months where like 30% of the time the frequency is on the higher side or beyond the set limits. And we are expanding the ISTS substations because we need to add more solar capacity, but those ISTS stations are utilized only for whenever the sun is shining and the solar assets are generating the electricity. Rest of the time, they are just idle. So, not to mention about on the load management, the DISCOMs have to manage the load and face penalties in case there is an excess drawal or an under drawal. Definitely, energy storage is the answer today. And we are all should be, kind of, fortunate that, energy storage has not only just become a technological solution to solve these problems, but rather it has also become an economical, alternative to the firm and dispatchable conventional sources. So this 24 has seen a lot of action, I would say. I think that should be we can say that is the year of energy storage. We have seen the storage tariff falling to nearly 2.1 rupees per megawatt per month. So roughly translates to about 2 to 2.2 rupees for cost of energy to store. And that has fallen almost from like 10 lakhs from the earlier tender. And we have also seen that solar blended with storage for 2 hours fallen to nearly about 3.09 in the last tender, and 3.45 rupees per unit in case of solar plus 4 hours of energy storage. So you are shifting the solar energy to the evening peaks. So this is no more definitely a technology on the lab level. The industry now needs to gear up for manufacturing and localizing it. And as Sujoy and other panelists have spoken enough about it, I think that is the need of the hour for all of us. And in terms of what we are doing, so Anvi Power is a part of the Gensol group. So at Gensol, our primarily mission is to accelerate the clean energy transition. All our portfolio is defined by that. We're into the electricity, renewable sectors, doing solar EPC, solar assets O&M, and the solar tracker manufacturing. On the mobility side, we have electric mobility brand called Gensol EV, which was showcased very recently. And apart from that, we also operate that Blue Smart as a all electric ride-hailing app or a taxi service. So coming to Anvi Power is primarily will be focusing on energy storage technology and manufacturing, where we intend to set up about 8 gigawatt hours of energy storage manufacturing in the coming months in 2 phases, in the coming years. The first phase of it we expect by March 26, and the second phase a year after that. And subsequently we want to not just stop at assembling or integrating these solutions, but also into eventual cell manufacturing for energy storage as well as for electric mobility. Yeah, thanks, Suresh.
Excellent. Thank you, Satya. And Kaushal, to you.
Good afternoon, and thank you for bringing me here. So obviously, we do have the sources which can generate the energy from renewables. The only problem is that it's not continuous, it's intermittent. Like sun would be for whole day, wind would be maybe in the evening and the morning and the monsoon season. And if we have to move towards net zero, and this is a ground zero for that, so we have to work something wherever we have access, can store, and whenever we require, we can use. We cannot compromise on our comfort. That's the first rule. Is if we have to do any technological development, we are not looking back to go and start looking for that's okay. We can manage with that, but we cannot we cannot compromise on comfort. But then we wanted to also move towards net zero. If you look upon the scenario, the energy storage concept is not like very new. We have been doing from the past also. We have hydroelectric power plant. That's basically storage. We use the water to store during the rainy season and we utilize it for the rest of the year. But then that's again very particular, very limited time what we do. And if you look upon the generation from the renewable sources, mostly from solar and the wind, what we talk about today, correct? So that's on the day basis, and that's where we talk about short-term storage. And when we say short-term storage, then mostly it goes to the lithium-ion batteries, and we have started working from 2016 onward on that particular side, looking for that's okay, if we cannot have the chemistry right now, can we have the cells, and from that we can make the pack. And today, what we have, you would be able to see whenever you visit down, we have a megawatt hour system at 800 volt running, powering up this particular research park and allowing it to move more and more renewable. And such examples can be done everywhere else also. Obviously, China is leading on that particular side, but it doesn't mean that we cannot do. We started working on the cells, we started working on all management part of that also over the time, and we didn't reach there at one go. We started working 1 kilowatt hour, 2 kilowatt hour, 5 kilowatt hour, 100 kilowatt hour, and then 1000 kilowatt hour. Now, the system what we have made is scalable. It can cater to even gigawatt hour. So that's a learning what we had, and certainly we feel that most of the things can be done here. But we also stay in the global village. We cannot expect everything to be done here only. We also have a dependency on others, like if we have to work on the electronics, maybe we can get it from somewhere else. If we have to work on something else, we have to get it from somewhere else. So with that, I'll stop here.
Thank you, Kaushal. Please.
So continuing from what Kaushal said, so battery cells, that technology is one part, but how do you really get the best out of the battery, and how do you make sure that it is safely operated? There's a lot of technology and electronics that goes in electronics, and there's a lot of software in batteries, and battery management system is the brain of this, and that's emerging technology, and there is a lot of research that is going on to make sure that we get the best out of the batteries, maintain them at safe operating limits, and get into our ground zero for the net zero. Yeah.
Excellent, thank you. So as you see, we have a cross-section of experience on our panel, starting from Devi Prasad, who's helping lead an organization that's bringing different stakeholders together, to Satya, who's putting actual systems together and getting into cell manufacturing, and then Kaushal, who has first-hand experience with a 1 megawatt hour system here, putting it together and then integrating into the grid, and then also an expert on BMS electronics, which is an underrated part of a battery system, but clearly the brains of the system. So we have this very broad cross-section. So I'll lead it off with a question. We don't have a lot of time, unfortunately, but I will lead it off with a question, asking each of you to, maybe from your perspective, from the way you're seeing the industry, what do you see as some of the opportunities and the challenges to meet this very aggressive roadmap of getting a lot of energy storage online by 2030? Maybe we'll start with you, Devi Prasad.
Okay, so opportunity is huge. So both on the mobility space and also on the stationary storage space for the behind the meter side, telecom, data centers, residentials, all have a huge opportunity. And similarly on the grid side, directly balancing the grid and also the generation. So, and also on the distribution side. We are expecting around 600 gigawatt hour of requirement by 2030. But this opportunity only can be captured if you can address some of the concerns. Some of the concerns still, like we have mentioned to consider in the budget, which includes one is on the GST disparity, like in the EV it is 5%, batteries at 18%, some technologies, non-lithium is at around 28%. So it need to be considered appropriately. Similarly, in the skill development, as we told earlier, we have asked for we have institutions on solar, wind, and everything like NISC, NIW. We need institutions like National Institute of Energy Storage to focusing on the fundamental research, because now it is maybe a small department for any universities. It should be a mainstream focused activities. Similarly, on the project side, how we have a ALMM structure to giving incentives to who are making modules in India. On the solar side, we should have also similar structures for the indigenous developed BSS systems need to be given priority on the deployment instead of imported systems. And when we're going for the cell manufacturing, PLI is a good step, but we need to go to the back side, see that in a battery cell, there are many components that need to be incentivized to process process from mining to refining to processing in India. So we have asked around 9,000 crore to create a PLI-like scheme for a cathode, anode, electrolyte, separator, and copper foil manufacturing, so that you can have a holistic approach to capture the full value chain. And also on the, yes, we understand there are some exploration is happening on the critical mineral side in India, but also on the acquiring the large assets from few of the mineral rich countries. Maybe Kabil is a long way, but we have to find out a subtle way and quicker ways to capture the mines in many countries. That's on the manufacturing side. Similarly, on the testing and standard sides, safety is the one of the concerns which has been addressed in the two-wheeler space in by AIS standards in 2022. But similarly, on the BSS system side, when it is just a nascent stage, we need to have appropriate safety and standards for the using in the BSS system, because now 16 gigawatt hour with large scale systems will come to the grid. So we need to have monitoring system certification standards, so that we should not buy from just considering the low price from some countries. And when it is going and the accountability and monitoring of the system, that is also need to be considered, because when you develop a project where BSS system is it monitored properly, the state of health is monitored or not, and when the project is completed after 10 years, the procedure for the decommissioning, like it is safety decommission and it will go for a second life usage if it is some is left, or if it is going for a recycling, that testing standard is yet to be developed. So lot more things to do, and there is an opportunity where Indian entrepreneurs can enter. So everyone cannot be a cell manufacturer. If you think everyone can be a cell manufacturer, there is you cannot go to compete with the economy of scale with large companies. So you can go to the any process like BMS or maybe container, maybe just working on the testing and certification side. Huge opportunities in the market.
Excellent. Thank you, Devi Prasad. Maybe Satya, from your perspective, what are the opportunities and challenges?
Yeah. So we have seen that, solar took nearly about like 10, 12 years to reach a scale of annual market of 10 gigawatt per annum. But look at the storage in the last couple of years back, there was hardly any project. And today we have already 15 gigawatt hours energy storage systems have to be delivered in the next 12 to 18 months. So that's a huge opportunity. And, I was always challenging Dr. Rahul that, the storage cannot go so fast. But this all have changed in the last, 6 to 9 months with falling battery prices, technology innovations, various factors. So there is a lot of opportunity for the industry to really step up to the occasion and capitalize on this. So we will see this growing up to 15 to 20 to 30 gigawatt hour much before probably even 2030. Maybe by 27 we need 20 to 30 gigawatt of battery manufacturing if we have to address this from the Indian market. So we need to manufacture today the containerized energy storage systems and its subcomponents, not to emphasize less on the subcomponents. Like we manufacture, like any, in an automotive factory, like on a serial production, we need to manufacture these systems, not just, talking about the cells through PLI programs, but we need the system manufacturing capabilities as well. And the significant challenge here is that, both in terms of deployment of these energy storage projects and manufacturing, and Devi has rightly touched upon a couple of them. Technology, financing, and the policy support. These are the key aspects to make this industry a success story. It is the time now that we have to act on all three of these. Talking about the technology, we have the containerized energy storage systems. We don't have really that kind of ecosystem to manufacture all the subcomponents or source locally and manufacture them in India. And like in my earlier panel, we talked about a simple product getting the right quality. We are not able to get that really. Whether we talk about components like the containers or the stampings of the hosting, these are not really technology intensive, but what matters is the scale. For example, I'll take that, there is a company in China which manufactures half of the world's containers, whether it's marine containers or the BESS containers. And for them to break even, they have to manufacture at one facility like 60,000 containers. So that's like 30 gigawatt. You know what the country of India would require in terms of energy storage. So we need to, it's really difficult to catch up with this kind of challenging competition that you face in every component. So there has to be a policy support, like the ALMM or similar to ALMM or the tariff barriers, and without that it's really difficult to sustain and keep this industry towards grow this industry towards localization in terms of whether you talk about the components or even the cell manufacturing. So I think apart from that, yes, funding is, again, while we talk about so many projects, we require billions of dollars of financing to be done. And we always hear that there are a lot of institutional financing committing, but when it comes to funding the project, it takes a lot of time and a lot of efforts to educate the system engineering. And eventually, this comes at cost. The technology is new, both in terms of cost as well as the financing rates or the time that it takes to get funding for the project. This remains a challenge. And thirdly, I think in case of automotive, we did a very good job in terms of, say, the AIS standards. They talked about some technical and safety requirements. AIS has set a very good benchmarks in terms of how these systems are designed. Whether you import or manufacture locally, you have to follow certain safety, functional safety and design requirements. We need that kind of industry standards for energy storage also. Yeah, with that, yeah, Suresh, over to you.
Thank you, Satya. Especially with batteries, given the propensity to catch fire and lead to large-scale safety events, the safety standards become really important, and especially on quality of imported cells and how they are matched. And we talked about it before, that there have to be standards that help us source cells and then be able to put them into batteries. Thank you, Satya. Kaushal, from your perspective?
So if you look upon opportunities, say I work mostly on R&D side. So R&D has a huge opportunity, because if we do something there, then only it could be used by a manufacturing company or other thing. So everywhere, including the cell. So we are a country where our temperatures are something like -40 in Leh and Ladakh to +51 in Jaisalmer as well as in Delhi. So Delhi is almost like a Jaisalmer during the summer. So if we could have something that cell level itself we talk about, either we talk about lithium cells or maybe a variant of that, that could look upon on that temperature range, can be work around not at 25 degree, maybe 35 degree or 45 degree. Because lower side temperature is easy to handle. Higher side temperature is you require additional energy to maintain that. So a lot of work could be done on that cell side, especially masonry. The second unfortunate thing, if you look upon that, that's okay, we do have the technology we developed in the lab, but how do I produce at the mass scale? And that's completely dependent again on other side. So during the R&D, if somebody is working on the cell chemistry, chemical or chemistry domain people, and a mechanical, electrical, electronics people is working on how to make this in a production form by developing the equipment. So there's a huge opportunity on that particular side. On and above, it requires a lot of electronics. So I'm not saying that component must be designed, electronic component must be designed. But then as an overall system of electronics, there is a huge opportunity again. If you look upon as an overall on the design side, so you have the mechanical design, so a small pressure. If you look upon the cell stacked together, correct? To make higher voltage or higher capacity. Stacking, you require some small pressures. Even finding that optimum pressure itself improves the cell life by 1,000 cycles. And looking on that side, you can have the improved cycle life even with the limited money what you have been putting earlier also. Then the mechanical design, the thermal design. Can I have something which could require the least energy, because it's a parasitic losses. You're not getting anything. At the same time, it will improve your round trip efficiency, because when we talk about round trip efficiency, it's not only the cell level, we talk about the pack level or container level. So today we are at, let's suppose 96%. Can I improve it to 97%? Can I improve it to 98%? So if losses would reduce further, then we can have a better energy utilization and the better cost for that particular system. And on and above policy side, I don't work much, but I believe that there is a sufficient uh, initiative from the government side. There is sufficient initiative even from the finance side, financial institution side. So they are ready to give you the loans if you have a proven track record, or even if you are coming at a new way. So there are opportunities. We have to grab it, and I believe we are 1.5 billion people country. Even 1% people work on this area, we can certainly outpace everything else, and it not only be adaptation, people would follow to adopt whole worldwide. Thank you.
Thank you, Kaushal. And you started off by talking about the BMS, which people, it doesn't get the same level of scrutiny as lithium or cobalt or nickel, but it clearly is the brains of the battery. So maybe if you can help educate us on what are some of the challenges that designing a BMS poses, and how can we overcome that?
Yeah, so BMS, when you design a battery pack, you start looking at, depending on the size or capacity of the pack, you look at whether you're going to manage individual cells or if you're having a large battery system. So you'll have hundreds of cells. You cannot keep monitoring with one battery management system. So you need to have a modular or a distributed management system for collect. So data collection is very, very important in storage systems, because you need to know how a cell is performing, how much is getting heated up, how much current is flowing through that cell, and what's the temperature at different performance or C rates that you charge and discharge. So when your load is very high, if you're going to discharge at higher C rates. So depending on the chemistry of the battery. So there is a lot of data collection. So you need to engineer your battery design along with the BMS to make sure that you collect every single data about the cell and about the pack. And then with this data, there is a lot of analytics that can be done, which will eventually help to improve the performance or even the design of the battery. For example, he mentioned, the pressure, how you pack it. So that will definitely reflect in your cell's temperature, or how much of C rate it can accommodate, what is the nominal range that can be done. So all that data can be used to improve this technology also. So the BMS plays a very, very crucial role. So BMS can be a single unit, or it can be a modular unit. So if you build it modular, structure it in a modular way, you can increase, eventually it's very easy to expand in a containerized ESS. So today we started with a megawatt hour. We can go to several megawatts or even gigawatts if you have a design built from grounds up for such expansion. So the design along with the battery and the battery management system, the data collection, the data analytics. So BMS is one part. And when you're building a large energy storage systems, there is a lot of integrated management also that has to come in, right? And what is the requirement of the particular, let's say for this building, we have built an integrated energy monitoring and management system. So where we look at the multiple entities and the battery, what is the requirement at different seasons, and what kind of renewable energy we are getting from solar, from wind, and what will be the requirement, predicting what will be the requirement for the next month, or when we are having such an event. So what will be the increase in the cooling requirement, which will require additional energy. So all that, can be, it's like a digital twin. You can build a digital twin using, your BMS, the data collected for the battery and other, storage entities in an entire system, in a network. So there are a lot of opportunities, and it's very nascent now, and we can put a lot of focus and derive the best out of the energy storage systems by looking at all the data and then designing the right solutions for us. Yeah.
Absolutely, thank you. I think with these batteries for energy storage, they have to last a long time. So being able to get the data to figure out how to optimize the performance is going to be very key. So with that, we'll conclude today's session. Thank you all. Thank you for the panelists for being here and giving us some very insightful comments to think about. And thank you all for your participation. And with that, we'll close this session. Thank you.